Okay, let's calculate the density of air in SI units at 1 atmosphere and 15 degrees. So we only have one equation that we know of that can solve this, and that would be our pressure is equal to density times RT. So let's write down what we know. Well, we know the pressure is 1 atmosphere. And so when we talk about atmospheres, that's the atmospheric pressure at sea level. So that's about 101.3 kilopascals, or 101,330 pascals. Our temperature is given to us as 15 degrees centigrade. That's our relative temperature, though, so we're going to need to add to that 273 degrees, because we want it in the absolute temperature. And that gives us 288 Kelvin. And last, we need the R value of air. So we can look that up, and air is 287 joules per kilogram times Kelvin. So what we're going to do is we're going to rearrange this equation, because that's not what's going to give us, because we want density. So if we rewrite this, it's density is pressure divided by RT. So at this point, we'll just plug everything in. Our density, 101.3 kilopascals, so that's times 10 to the third. And a pascal is a Newton per meter squared. And I broke it down like that to make things a little bit easier to cancel out units. So on the underneath we have R, which is 287. So a joule is a Newton times a meter divided by kilogram times Kelvin. And then we're going to multiply that by 288 Kelvin. So now if we sit here and we start taking a look at things, I've got the newtons that cancel out. I actually have the meters, they're on the same side of things, so that's going to become meters cubed. The Kelvin will cancel out, so I'm left with 1 over kilogram. So units, I'm going to end up with kilograms per meter cubed, which is what I expect. And I do the math, and I get 1.23 kilograms per meter cubed as my density of air at 15 degrees.